Today's Tuesday, January 17. Review for Assessment 1. Do problem D and H. I'll do it in just a moment. If you've forgotten, check with a neighbor. You should have some work on there that reminds you.
Oh my God.
For those who have figured out, you know that it's going to be a fraction that 120 over the 180 with a pi. Pi can be upstairs, could be behind. Nonetheless, when I'm reducing a fraction, of course, you know, you cross out the zeros. Again, if you turn in this sheet as 1 to 6, it's true you have to do the entire sheet. Then you reduce this fraction. 6 goes into 12, 6 goes into 18. So we wind up with a 2 2/3 pi, or 2 pi over 3. See how you feel about it. It's not supposed to be tricky.
Are you gonna give us a unit circle on the test?
For the for standard 2, where you're choosing the cosine and sine, which isn't their intent, but I'm gonna do it. Yeah, that's one time I'll be kind, where it's like, okay, I'll fight for them on this one. Yeah, I'll take it. All right, here comes H. I know some of you didn't get to H, but I'm gonna go for it anyway. Oh, pause. Any questions on D? Okay. Standard 1 is going to be a freebie. They're either going to give you a degree, switch it to radians, or they're going to give you a radian, switch it to degree. It's just like, at this level, I'm no surprised they went straight forward on it, which is why there's one extra problem I'm going to highlight where they're going to take it to the next level. And I want some of you to have access to it. Nonetheless, 31, this one we need help with the math. 31 over 18. All right, I know I need it in order for it to be degrees.
180.
The pi's have to cancel, which is why they have to be on opposite or diagonal from one another. All right, help me out. 180, the pi's cancel. 180 times that 3, 55, 60 I hear from one person.
Wait, what is it? I thought it was 55, 80.
Is it 5580?
Yeah, should be 80. All right. Multiply the top, divide by the bottom. Multiply the top, if you work here, 80, divide by the bottom.
300.
I believe it came out to 310.
Yeah.
Yes.
Take a look, see if you want to have something. All right, on this one, do me a favor, you didn't write this part. Please put a 1. Please put a 1 next to the radius so that we know that this is a unit circle. This 1 next to the radius is actually going to be important. Over here on this second one, please also put a 1 next to the radius so that you know this is a unit circle. Today you may encounter a circle that has a 2 or 3. And here's what I want you to know. In particular with this one here, we can say it with both of them, but I'll say it with this one here first. In this problem here, they gave you the radian. They told you the radian was 4 pi over 11. Please put it out there. Also, if you had a highlight, I'd want you to highlight that what you just marked was essentially the crust of this circle. That's how much of pi you have. You don't even have half of it. Half of 11 would be 5.5. So here's what's true. This pizza here, whose radius is 1, if you cut it, you would have 4 pi of its crust. 4 pi over 11 of its crust. Now, if we were to double the size of this pizza, the crust, the size of it would double as well. In other words, if I switch the number, which I'm about to do, I'm going to do it like this. Do your best as best you can. We're going to draw a circle that's twice the size of the original. Try to do what I'm doing. This is going to mess some of us up, but try and write it down.
What, really? That's stupid.
Try and do what I'm doing.
I won't spot it.
That's so stupid.
Wait, what's going on here?
It's so entertaining.
I'm making another circle.
No, we're making Pac-Man.
Try and make it look as best like mine as possible. I'm just trying to I'm trying to blow up the circle that's in the middle.
That's the moon.
And I'm making it 3 times the size.
Y'all suck.
Seriously getting it that way.
If you have a highlighter,
Of all people, you think getting I do.
No, it's not suck.
Yo, I got this, bro.
Say it again. That's not
Because
moon.
Star Wars.
Yo, do circle this.
keep this. All right, do your best to try and draw what I just.
Maybe the people at home are level.
All right. Anybody missing? I know about 3 people missing. All right, so here we go. Let's see if you can follow this. It's a simple concept. If the amount of the radian I gave you when it was just a 1 is 4 pi over 11, if I were to double the amount of radius that I gave you, it would double the amount of the radian. Well, in this case, I didn't just doubled it, I tripled it.
Whoa.
So the question is, if I know how much this guy is, and all I have to do is to triple it to find out how much this guy is, the question is, how do I write that?
Well, bye.
How do I say that I'm going to triple it? And I heard the answer, but I'm going to show it. The answer is the following. To double anything, of course, you just multiply that thing by 2, but we're not multiplying by 2 because we are tripling it in this case. So in this case, we're actually going to multiply it by
Thomas,
3.
the test, would you accept this if I give that answer?
No.
Do it the way I do it? Mm-hmm.
No, sir.
All right, so here's the deal. This is not the final answer. How do you get the final answer? How do you multiply a whole number times a fraction? Kind of like Jose suggested. You're going to put that over 1, top times the top, bottom times the bottom, and you are done.
So it's 12 pi.
12 pi all over the 11. Take a look at it and see if you're okay with where those numbers came from.
Oh,
94. And respond to that question, please. I'll come around and check mark it in a moment. Why am I not on 94 right now?
Best kickers in the league. Best kickers in the league is Tucker,
Gross.
Please read the question on page 94 and see if you can respond to it.
94.
I don't know. You want to?
Whoever pays attention.
I never paid right where you guys.
Oh, it's
Oh no, football. I know that they roll.
Oh.
Is it just this?
Oh no. But
Broken it.
All right, let me read the question because they're asking a little differently than I asked it. I want you to understand that it's asking the same thing. So let me say it. It says, what is the measure? I'm going to erase all this stuff I needed for the last page.
what? No, it's oh, I see.
So here it goes. What is the measure of the central angle? Shh. For those who are talking, please stop. It says, what is the measure of this central angle when it is not a unit circle? Underline that part. The radius is not 1. Double underline that. It says the central angle is 2 pi over 3. This is the one moment I'm going to say it so that you will have heard it, just in case another teacher says it. Whenever I talk about pi, I tell you that it is the crust. And that's the way you really should think of it. But what you need to understand is that technically, the radian not only is the crust, but you can also use it as the actual angle. So if someone said, hey, what is the central angle here? Normally we would say something like, oh, it's 45 degrees. Technically, you could also say it's 2 pi over 3, the actual angle. Now, because most of the time when we're getting the answers, they're using it on the crust, I always refer to it on the crust, or on the arc length, the official name. But I just want you to know, because in this sentence, they're talking about the central angle is 2 pi over 3. Somebody may say, that can't be right, an angle can't be a pi, only the arc or the crust can be. But technically, both the crust and the angle can be referred to that way. That said, still think of anytime you see pi as the crust. What is it that they're asking you here? what is the length of AC? So here's all they're saying. What is the measure of this central angle when it is not a unit circle? In other words, the radius on this one happens to be a 2. The original problem began when it was a 2 pi over 3. They want to know what has happened now that this circle has been stretched where the radius is a 2. In short, due to this problem, what we just did to the last, and you will get the correct answer. It's just the way they're asking it that seems weird. If you back up to the last page, we stretched it to the radius was equal to a 3, and we got an answer. This time, they're only stretching it where the radius is a 2. Oh, we got it. All right. Some people, once you get it, you can raise your hand, not come around. But in short, due to this problem, what we just did to the last. And again, I sort of apologize because it's not teaching you the way Common Core, you have to think a little bit. Me, I'm just telling it to you.
We hate Common Core.
Can you read the last part?
What's the last part? What did you hear last? So I know what the last part means. What is this problem? What did you do to the last? That's the last thing I said. It started off already with that. Take a look at it, take a look at it. One other hint, just in case it happens. This part is not part of the problem. Imagine they stretched it to a... Yeah, let's do 6. Say they stretch it to 6. Here's what's important. Your 2 pi. They would not write 12 pi over 3. Can someone tell me what they would write?
4 over 1. 4 pi over 1.
Excuse me.
They would start with that 4 pi over 1, because 3 goes in the top and the bottom, but they wouldn't write it as a fraction at all. Since 1 can go into it, yeah. So just be aware, I did a different problem just to make a point, which is, if when they multiply it on the top is something that can be cross-canceled with the bottom, it can be reduced all the way to a whole number, they won't leave it as a fraction. If when they cross-reduce it, it stays as a fraction, then it stays as a fraction. So I just wanted to highlight that part. Let's see. That's standard 1. Any questions about the leave standard 1? All right. Standard 1. Please write down cosine of 135 degrees. Write down that and write down the answer, the exact value. Write down the sine of pi over 6. Next one. Write down. Let's see if I can get a negative thing in here to mess with somebody.
Oh, it's not a curveball.
Sure, we'll see. We'll see what they do with it. Write down the cosine of negative pi over 2, the exact value. Now, if you don't know what that negative sign tells you, then you won't be able to do it. It's easy if you know where to go. If you don't know where to go, then it becomes tricky. That one I'm going to share with you. And then, let's see, there's one last one in this section. These are exact values. We'll do 2 that are decimals. We'll see what happens with this. Decimal. These last two you need to do on your calculator. To get to pi, I think you have to go to, is it blue button, and is it the right under the caret, or is it the caret button?
Yeah.
It's the actual caret button. You're going to do, I actually don't know the answer to this one, but we'll do cosine of 210. And then we'll try this one. I know the answer to, so I'll do this one. And we'll do the sine of pi over 2. I wonder why I did that 210 instead of. You know what? That 210. Let me change it to 7 pi over 6 because I think your calculus should be in radian mode.
I just changed it to radian mode and it's doing the same thing as it is.
You agree? It's doing both? Okay.
Do it.
And for anyone who wasn't here to know how to mess around with your calculator that way, do me a favor for just a second. Everybody hit mode for just a second so that you will see where it says radian and degrees. So try and punch that one in. Try and hit mode just so you can see where radian degree is. I'm going to have you switch it once and switch it again. Everyone switch your calculator from radians to degree mode. In other words, you hit mode. So Jacob's just going to punch that in. You're going to hit mode. And then once you get there, slide it over with your gray arrow to degree. Hit enter. And right now, if you were to arrow down one, you should have degree is the shaded color. Now we're going to turn it back. Take it back to radians. Hit enter. Arrow down, gray with the arrow, so you can get off it, so you can see that radians is highlighted. Once you do that again, you can go back, put in the appropriate answers for each of the questions, and your standard 2 you should finish. So again, because for one of them, well, when you do the calculator version, you are going to get a decimal version of the answer. So these up here, so I can highlight, these up here I want it exact. The minute you know it's exact, it's one of the fractions that you're just tearing right off. Exact value is the phrase you're going to use, so you need to know that phrase. Exact value.
Yeah.
So again, you are getting the decimal version right now. So check with a neighbor. You weren't here that day? You don't watch the videos, do you? Oh man, you gotta. But check with the neighbor. All you're doing is punching it into the calculator. But check and see if Sammy, did you punch that in?
I don't know what I'm doing either. Don't tell people to ask me, please.
Maybe I could switch Jose and you two push down that way and Jose can swap Sammy seat.
Jay will help him?
Yeah. I know less.
Yeah. I just don't know.
I'm changing cosine to 7 pi over 6, and I'll put in a third one on this one. Let me do a third one so that
Adam, where is your guys' conversation? You talk about like there's overdose and shot in the head. Why? That's such a terrible way to go.
That's how I want to go.
all right.
You wanna go all
Write down the problems on the board.
Jesus.
All right.
Nobody can fight tonight, you guys.
I'm assuming it's in your sleep, right?
All right. Let's do 2 easies, and then when we get to this section, some of you will be like, "What? That was it?" Yeah.
It's not like that.
Well, I want to.
For the majority.
All right. Let me have your attention. Let's do some of them together. Shh. I wanted it to feel that way so that you can see, hey, shh. Those who are talking, hold.
Hold the door.
I wanted to do it that way just so you can see, okay, is it really hard or do I just not know how to do it? And the answer will be, to those who are talking, just hold a moment. The bottom ones aren't going to be too bad. The top ones I saw people have, someone say what the cosine of 135, please?
Negative
135, I see it right there, so it's negative radical 2
Okay,
over
that's
2.
what I originally wrote. Okay, we're good.
So for those who weren't here last time, to get the easy ones, remember it is always cosine, comma, sine. I should write this just I don't want anyone to miss these. Without the calculator, you can still get a 2 in this section. The first fraction is the cosine. The second fraction is the second cosine. You do not. When they say exact value, if you use a calculator, you're going to get the wrong answer. Exact value is code for choose one of the two fractions. What was pi over 6?
1 over 2.
Here it comes. Yeah, 1 over 2.
I see what you're asking for now.
Take a look at you will. They kind of want students to memorize it, but I'm not going to go that route this time. Any questions on the easy ones? All right.
I had to write the first one.
That's why I wrote down this phrase, the exact value, to see if anyone remembered what that meant. And some people did. All right, here it comes.
Wait, what does it mean?
The hard version.
How's that hard?
Let me do 7 pi over 6. When you punch in your calculator cosine 7 pi over 6, what did we get?
Negative 8 and that's 6.
I got that.
Say it again. Say it again.
Negative 8.
Negative 0.6. 6 repeating.
I got that in
So it's around it.
What?
radians, and then I changed it to degrees, and I got
It's
0.6.
And I think this is
So it should be in radians
It should be negative 8.
Yeah,
because of the pi.
Oh, okay.
Say it again.
Thomas is negative 8.
0.86.
Oh, thank you. Take a look at the board. Punch it into your calculator to make sure you get this answer. Now, I wouldn't want anyone to miss this because it's just punching it in. The only way you would miss is if you can't find the pi button. Put them in parentheses. I'm going to come around to see everyone's calculator. So everyone punch this one in and hold it up so when I come I can see it on your calculator. Pi over 2.
1.
Yeah. Now, I did that one on purpose so that you could see on here pi over 2. It happens to be 1. So they're not going to do that kind because you could just take that one off the chart. Last one, pi over 3. I'm about to do that one too. Pi over 3? It's 0.86 again? There's a 6 repeat? Oh. Interesting. Pi over 3. Oh, okay. That makes sense. Because this one here, radical 2 over 3, same two numbers.
So, no, the last one is positive 0.86.
Write it down, write it down.
The other one was a negative.
Oh,
Yeah,
yeah,
the
demonstration.
Write it down, write it down. Pi over 3 is a 0.86 and it continues.
I got that one right.
Was there?
Alright. Any questions about the decimal version?
I know it's something shape.
You have -1 on pi over 3?
But that's not right.
I'm looking at Sam. You want to go to any paper?
Why did I?
I'm about to study for physics.
As long as you write in the thing, then that'll be fine. Yeah. Calculator, if they say, please find the decimal version. And I think on the test, the exact way it will actually say in parentheses, no calculator. And I think this one may actually say calculator. Last one in standard 2. What was cosine of negative pi over 2?
0.
I hear 0. It's true. To go the negative direction, you have to go this way. Pi over 2 would get you right here. Here's positive pi over 2. And here's negative pi over 2. And so it gets you right here. You said it was 0?
On purpose.
Take a look, see if you have a question.
So if you were asking for sine negative pi over 2,
You want me to bring me the
Uh-huh.
book? You got it.
it'd be -1, not just 1.
You are correct. It would be -1. because that's the second number in the.
Is it always going to be straight across? Let's say you're putting cosine negative pi over 6, right? So would it be 5 pi over 6? Would it be negative pi, square root of 3 over 2? Straight across it?
That one, let's see, 5 over 6 is right here.
Yeah.
So negative 5 over 6 would be right here.
Oh, okay. So if it's 1 away, then it's 1 down. Alright.
If they ask you for the, let's say, the sine of 720 degrees, here's what it means. To go 360, you go around once. To get to 720, you have to kind of keep going, but how much more do you go? You just subtract 360 from here to find out, well, how much is it past 360? In this case, it happens to be another 360. In other words, to get to 720, you just wound up right back at the beginning. So when they say, hey, what is the sine of 720 or any big number, your job with that big number is to keep subtracting 360 away from it until it gives you a regular number, that is a number that's 360 or smaller. Once you wind up there, then you can get the sine of 720. It's just the second part of it. Again, this is a B question. You don't need it. The other version of this is they might ask, what is the sine of, let's say, like 13 pi over 2? Okay, how do I do 13 pi over 2? The answer is turn it into a degree first, and then whatever number that gives, which I'm going to try and do with someone's help, whatever number that gives, then you would do that. But again, this is a B. If your brain's looking at this going like, huh, let it go, do your 2 exacts, get your 2 calculators, and move on. Someone do me a favor though, to turn this into a degree, someone do 13 times 180 and then divide it by 2.
It's 1170.
Whoa.
Yeah.
A joke. Wow.
1170 is the final answer, or that's good?
That's the final answer.
Okay. The question is, how am I going to find the answer to 1170 degrees?
Keep subtracting 360.
Yeah, you can keep subtracting 360, or for those who can get it, if you divide 360, it's 90. Oh, is it 90? I was going to say if you divide 360 into, so I'll do 1170 divided by 360.
It's 3.25.
Alright.
Just go around 3 times.
Right, and then that other 25, 1/4. But for those who don't, just subtract. That's an 8. That's that small in 360. Subtract again. Now again, this is a B, part B section. So again, not required, but it's not super hard. 360 again. I'm going to stop here. Subtract it one more time. I guess I'm not stopping there, am I?
Isn't it just 1?
There's a 90. So what they're saying here is, when they say the sine of this,
There's too much writing there, I guess.
yeah, clearly it's terrible or whatever.
Can we,
Sine of 90 is a 1. Do you need it? No, but if you get it, if you want to mess around with it, you can try it. All right, we got about 6 minutes to draw a sine wave, which is the hardest part, so I probably should take as much time. But these first 2 sections should be fast enough, or you still have enough time to do the last part. Let me pause. Anybody who is dealing with the B section, do you want to ask anything about the B section in Standard 2? The stuff I just did.
Okay, so what if it...
Go.
So what if it's not something easy like 0.25? What if it's something a little different? How would it count that?
Because they're if you did the division version, then it's true. If it's not an easy thing like 0.25, then you're just kind of messed up, which means you would just have to go to the subtract version, because it's going to end with a regular degree, and with the regular degree, now think about it, it should land on some famous point. In other words, if it landed here, even if you got there, you wouldn't know what that is, because we don't have an exact value for it. So good question. If it's a decimal that's wacky, then just go back to subtracting.
Over here.
Yeah.
Right now, this is the handout. Someone help someone. This is the handout.
It's the handout.
Oh,
It doesn't even have like anything else.
All right. Here it comes. Wait, how do you do this? Shh. I'm gonna do. Let me do this first one, and then I'll say something about the middle one. Then I'll see if you can fight with the hard version. Here it comes. Step 1. You need to draw a line of equilibrium. For those who aren't here, that means you slice the picture, same amount on the top as there is on the bottom. Second, because they're asking me for sine here, if you don't know what a sine wave looks like, a sine wave always starts on the ground floor of the equilibrium. It goes up once, down, and stop. That is a sine wave. Let me show what a cosine wave would look like on the same picture in blue. If they would have said, find the cosine, again, you slice the line of equilibrium. That's always the same, also called the midline. But a cosine has to start at the top, goes down, and finishes back up at the top. So this same wave can be described as a sine or a cosine. You have to decide which one you're going to use. If they don't tell you which one to use, the rule is generally whoever starts here at 0, use him. Or if they just give you that piece. So let's do the sine wave. Here it comes. What is the K in this problem? Someone tell me, please. Oh, they don't even know that. Okay, it is 0. But let me write out the equation. It's y equals a sine. Oops, I'm missing something. Y equals a sine B. Take a look at it. Write it down. Some of you should already have it. So here it comes. The midline, the red line, is going to be a 0. How do you know it's 0? If you're counting the y's, that's 1, 2, -1, -2. It's 0 right here. The midline is a 0. On this problem here, can someone say what the midline is?
-2, I believe.
Yeah, it's a -2. Okay. So again, over here, K is a -2. On this one, K is a 0, and I put it in the wrong place.
Yeah, why'd you have A as the midline?
Yeah, I messed up. Oh, shoot. Yeah. Alright, should have done this first. So we had maximum time. Where are you? You are a B. X minus H. Plus K. Alright. Take a look and see if you're okay with where I got the 0 from. And I'm going to do something. I'm going to write this second one down at the same time. I'm going to rewrite the formula. Y equals A sine B X minus H. And I think I'm going to offer you the formula.
You just let us use this page on the test.
Can't do that.
Please.
Alright.
You print off the
Yeah, I'll probably offer the formula. But no. Alright, here it comes. So I got my K. The K on this one is a -2. Take a look and see if you see where I got it. The most important parts to me will be, can they find the K and can they find the A? The middle part, I want you to do stuff, but as a teacher, I'm going to make an executive decision. Another teacher at another center just sent me a text saying, or an email, hey, this section is terribly hard. How are you doing with your students? And I'm like, the A and the K is important to me. The H, I'm expecting some of them to be able to do that. The B, I'm just going to have them put a B. They're not going to put in the B part. On the test, they kind of expect you to know how to get the B, but for me, I'm going to be all right without that. All right, here it comes. Let's finish both of these off. and then change it. All right, here goes. What is the A on this one? It is a 3. As high as it goes, or as low as it goes. It's the amplitude. We got a 3 there. What is the A on this one? Just a 1. If you understand that A, and you understand that K, I am happy with you, and you are smarter than most people out there. Just that alone. Now, what do we do next with that? For this one, it's still a sine. Nothing changes. I'm going to do one little move. Because it starts here, it didn't go to the left or to the right. Technically, it's x minus 0, which is really just x. Right, we're going to do that in a second. Don't do it yet. Don't do it yet. This guy over here, the middle. Take a look at the answer, see if you're confused.
Wait, what A? A's not even having done that, right?
Wait, what was H again? Is that a 0?
H is a 0 because it doesn't move. This is the line of origin. If it doesn't shift away from that, even if B stays the same.
Okay, that's B.
Yeah, B.
Ignore everything that says count.
Yeah.
And then K is what's K?
No. It has nothing to do with K. It's just. It's one way of thinking of it, but I would say don't mess with that. Just put the minus 0 because this is minus H. All right, here comes the hard part.
Plus or minus 0.
All right, here comes the hard part. We're about to do both of these as cosine, and I'm going to have you try and do a real one. We'll get that answer, and then you'll have to dive in. All right, here it comes. The cosine of this thing, cosine are the same thing. Here's the good news. The A and the K stay the same, which is why they're so important to me. On this problem here, it's going to still be a 3. On this problem over here, you're still going to be a 1. You are still going to be a 0, and you are still going to be a 2. Sine or cosine, the A and the K stay the same. What's going to change is something with that H. That H has to change. So let's see if I can help you out here. If we were doing the cosine, it would actually start right above this thing here. Is that a pi or 2? I can't see it.
Yeah, it is.
Yeah.
All right. B, X, and we move that way to the right. We move to the right. It's this one.
If we were to go into the negative axis,
Oh, my bad. I'm wrong. When you move to the right, it's the opposite sign.
why is it the opposite?
Because of the formula it says whatever the H is, you got to do the opposite of that. Take a look at this problem, please. Take a look at it. This is what I want you to see. Actually, I know. This section is a tough one. Over here, what would I do? It does the same thing, unfortunately, so now they think it's always that, but it's not. Cosine, you start up high, you go down low. How do you change that? We just shifted it over to, this is also pi over 2. All right.
What happens if it doesn't start on one of those? Like 15. Like 15 plus anyone starts.
Technically, good question. Marco's asking. This number here is actually pi over 4. Technically, it's another one they kind of believe you should have memorized. But, yeah. If it's not there, ask me. And I'll tell you right there. All right, last piece. You got 4 minutes before I put this test in your hand. So what is it that you're going to do with your last piece? Oh, this is going to sting. Page 70. Go to page 70 and try to do, they've done part of it for you. You can do the cosine version and then switch to sine, or you can do the sine version and then switch it to cosine. I know. I should have spent more time. I think I still will, though.
Which page?
Page 70. Is it 69 in yours?
Yeah, 69.
Page 69.
So you know what? Oh, really?
Y equals 4.
What is the K on this one?
5.1.
Yeah.
5.1. If you did a 5, I would take it. If you did a 6, I would take it because I know. Oh, no. If you did a 6, I wouldn't take it. If you did a 5 point something,
I got 5.
let's just say you did a 5.
I got 4.
I'm gonna put a 5 there. Okay. Now watch this. I just did 2 problems at once. Whether I'm doing sine, whether I'm doing cosine, I automatically get 2. So here is, some people are putting 5.1, some people are putting 5. I would take it. I would take it. What is the A, the amplitude?
I didn't put H.
I heard a 5.
I got 4.
4.4. I would take it. I would take the 4.4. I would take the 5.
Can I just do 4?
Write it in. Write it in. Some people put 5. Some people 4. I would take anything obviously right there.
Age.
All right. So here we go. Let me do cosine first.
We are trying.
Yeah, I'll do cosine first. Technically, when you see this problem, listen up. When you see this problem, technically, they would want the cosine version initially because that's the one that's at the 0 mark.
Oh.
Now, if you didn't do that first, you're not wrong. But when a mathematician looks at this, they go, okay, who's up there? Oh, this is going to be a cosine because it starts up like that. If you did the sine version, oh, no.
Wait, where does it start if it's sine?
Oh, no.
Right from the line?
It went down first, so there's going to be a negative sign on the A, which is a terrible thing because it flips it. But I would take it without the negative sign. So here we go. Let me do the cosine thing and then be sad about the sine thing in a moment. All right, cool. Wait a second. There's a sign over here. Yeah, there is. Okay, never mind. I'm not sad again. I'm not sad again. All right, so let me do the cosine. Hey, tell us what we're doing with cosine. I got my A. I got my K. This thing is right here at the beginning at 0, like it hasn't moved over. So you're about to get this thing now. I have to give it to you in a second, but take a look at these at the cosine answer.
Can you tell us what B is?
B is how many cycles.
I know, but like.
In this case, it just be a 1.
What?
Yeah, but don't worry about it. Take a look at the cosine. See if anyone want to ask anything. Oh shoot, 35 minutes.
Can we just test?
We just test and do our best.
Here it comes. Let me do the sine.
Bars.
The sine starts right here.
Thank you.
This is at what? This is 6, 7, 8, 9. Here's 9. Take a look at it.
Oh, that was
9 a.m.
That was
That's gonna be it's gonna be sine. So yeah. So for sine, it went all the way over to 9 a.m.
Wait.
So do we put 9?
Uh-huh. Here's the sine version. Take a look at it. See if you want to ask something about
So
it.
if it's at, cosine's at 12.
Cosine is at 12, which is the beginning of the problem, so it's like at 0.
Can I write 12?
If you'd have to write 12 mid, because your 12 would mean this one, and mark it.
Oh, switch to 0.
Yeah, do
Isn't
0.
there 2 12 mids though?
Oh yeah. But no, so stick with the 0. All right, anybody got a question? Yeah.